Hi Math2, this is a summary information for shifting cubic functions. If we have a cubic and we add c inside the parentheses, this shifts the graph left c units. Likewise, if we are subtracting c inside the parentheses, it shifts us right c units. And these should start to feel familiar. We did these with our square root and our cube root functions. If we add c outside the function, we are going to go up c units. And if we subtract c, we will go down c units. If we put a negative sign in front of our function, it reflects over the x-axis. If we multiply our function by some number, let's say a, then what we end up getting is a stretch because a is greater than 1 by a factor of a. And I should write a little a there. If we multiply and a is in between 0 and 1, then we have a shrink or a compression. By a factor of a. And numbers that would produce a compression would be numbers like 2/3 or 1/2 or 9/10. Any sort of fraction that is in between 0 and 1. Numbers that would produce a stretch would be numbers greater than 1, like 2, or 3/2, or 10/9. Those would produce a stretch. So let's see if we can put it all together and go in the opposite direction. It says, write a cubic function, shifted 11 units left, and a vertical compression of 1/5. So we start with our parent cubic function, y is equal to x to the third. And then we're going to do the things that it asks us to do. We're going to shift it 11 units to the left. Well, I have to do that inside the parentheses, so I'm going to have to erase a little bit. Shift it 11 units left, and we're going to compress by a factor of 1/5. So there's our function. Part B says a cubic function, we always start with a parent, shifted to the right 20. Okay, well, I'm going to have to put that inside my parentheses too. So now I'm shifted to the right 20, and this will flip me over the x-axis. A cubic function shifted 11 units left and 18 units down. That's that. And this is the last of your videos on shifting cubic functions.